Okay, let's take a look at example 2. And by the way, if you hear any noise like birds or traffic, I am sitting on the back deck today for my classroom. So if a toy rocket is launched vertically upward from ground level, so that means it's going to start it at 0, 0, with an initial velocity of 128 feet per second. And then there is our function. How long will it take for it to hit the ground? So that means we are looking for the positive root. We know we'll have one root that is 0, and then we will have a root that's positive. I know one root is 0 because this starts on the ground. So let's take a look at finding the root. The positive root will answer our first question. Now I'm looking at my equation and I don't have a C value, and I can see that 128, again, I have my handy dandy calculator available. Yes, 128 is divisible by 16. So I'm going to factor out a GCF. So I'm going to factor out negative 16, and I'm left with positive t squared minus 8t. Oh, guess what, guys? What should I have factored out? I still have a t in both of these, so Ms. Thomas should have used the real GCF of negative 16t. Now this leaves me with t minus 8. So I'm going to set this factor equal to 0 and this factor equal to 0. This gives me t of 0, which is our initial starting point of our rocket. Then the rocket will land in 8 seconds. So 8 seconds is our answer here. How many seconds will the rocket be 112 feet off the ground? So I'm given height, and I want to find seconds. So h of t represents height, total height. So I'm going to replace h of t with 112. Now, let's see if 112 is divisible by 16. It is. So first of all, we're going to factor this, but we need this side to equal 0. So we're going to subtract 112 from both sides. I think on my other answer key that's already been posted, I did not I think I used quadratic formula on everything, but I should have been smart and looked to see if this was factorable. A lot of times you know it's factorable if all your terms have a GCF. So now let's factor out a negative 16. This time I cannot factor out the t value because my constant does not have a t. So now we are left with t squared minus the 8 from earlier, and it's a t value, 8t. And then we have, so we're factoring out a negative from a negative, so that gives me a positive, and my calculator says 112 divided by 16 is 7. So now let's factor this using our graphic organizer. 1 times 7, and my b is negative 8. I have a value of let's see, it can only be negative 7 and negative 1, Miss Thomas, come on. Okay, negative 7 times negative 1 is positive 7, and if I add them, I get negative 8. So when I rewrite this, I'm using f of x. I should have used h of t, but anyway, let's just move on. So I have the negative 16, the GCF, and then I have x minus 7 and x minus 1. So when I set these equal to 0, that's false. Then I have x minus 7 equals 0, and the other factor, x minus 1 equals 0. So I get 7 seconds, and I get 1 second. So remember, with our parabolas, they go up and they come down. So at 112 feet, I have 2x values. So as it's going up, in 1 second, it's 112, and then when it returns and is at 112 again, that is 7 seconds. So I'm going to have 1 and 7, and that is seconds. How long will it take the rocket to meet its maximum height? So we are going to find, so we're looking for seconds and then the actual height. So let's change colors, and we need the vertex. So my vertex, negative b, let's put x equals negative b over 2 times a, and my calculator divided by gives me 4. Nice. I love when we have some nice integers. So it takes 4 seconds to reach its maximum height. Now, let's find out what that maximum height is. Ooh, loud motorcycle. So I get 4 squared is 16 times negative 16. That's negative 256. I have 128 times 4. That gives me 512, which gives me 512 minus my 256 gives me 256. So it reaches a maximum height, the rocket, at 256 feet. I know it's feet because we have an A value of negative 16. Very nice.